Cheap production feels smart until you zoom out. It feels efficient, rational, almost virtuous. Spend less, produce more, survive the season. That logic is drilled into producers, managers, and even governments. Cost down, margin up, repeat. On paper, it works beautifully. In reality, it quietly bleeds value out of the system. The problem is not that people choose cheap options. The problem is what they define as cheap. Most decisions are made by looking at the price tag, not the life cycle. Inputs are evaluated in isolation, not as part of a system. Fertilizer is judged by cost per ton, not by nutrient availability over time. Machinery is judged by sticker price, not downtime, fuel efficiency, or lifespan. Feed is judged by formulation cost, not animal performance or waste. This is where the hidden cost begins. Cheap production does not reduce cost. It shifts it, sometimes into the future, sometimes into the soil, sometimes into labor, sometimes into risk, and sometimes into failure. Take fertilizers. A low-cost fertilizer can deliver nutrients fast, but inefficiently. Poor solubility, rapid leaching, volatilization, uneven distribution. The crop receives less than expected. To compensate, the producer applies more. What looked cheap becomes repetitive. What looked efficient becomes waste. Nutrients escape into water systems, soil structure degrades, microbial balance collapses. Yield drops slowly, then suddenly. The accounting sheet never shows this as a fertilizer problem. It shows it as weather, bad season, or unlucky year. Cheap inputs create expensive uncertainty. The same logic applies to machinery. A cheaper tractor or harvester might perform adequately in the first season. Maybe even the second, but maintenance cycles are shorter. Parts fail earlier. Downtime increases. When equipment stops during harvest, the cost is not the repair. The cost is lost timing, lost quality, lost market windows. Crops do not wait for budget decisions. They rot, overmature, or lose value in silence. Labor absorbs another invisible cost. Cheap systems require more manual correction, more monitoring, more improvisation, more stress. Skilled operators leave, training costs rise, errors increase. The system becomes fragile. One absence, one mistake, one delayed decision and the entire operation stumbles. This is not bad luck. This is structural inefficiency disguised as savings. Cheap production also locks operations into short-term thinking. When margins are thin, experimentation dies. Innovation becomes too risky. Precision tools are postponed. Data collection is ignored. Preventive maintenance is skipped. The system survives, but it does not evolve. Over time, competitors who invested in efficiency, resilience, and data quietly pull ahead. Not dramatically, invisibly, until the gap is irreversible. The irony is brutal. The producers who obsess most about saving money are often the ones paying the highest long-term price. Not because they are incompetent, but because the system rewards short-term cost reduction while punishing long-term thinking. This is why cheap feels safe. It feels controllable. It gives the illusion of certainty in an uncertain industry. But agriculture, manufacturing, and production systems do not reward illusions. They reward robustness. The real question is not, how much does this cost today? The real question is, where will this cost appear later? Most balance sheets are blind to that question. Soil health does not depreciate line by line. Biological efficiency does not show up as a fixed asset. Risk accumulation has no column. Until it explodes, cheap production is not a strategy. It is a delay, and delays always charge interest. The first place where cheap production leaves a scar is the soil. Not immediately. That would be too honest. The damage is gradual, quiet, and perfectly optimized to be ignored. Soil is treated as a substrate, not as a system. As long as plants stand upright and leaves stay green, everything feels fine. But soil is not a battery you drain and recharge at will. It is a living infrastructure. And cheap inputs interact with it in the most inefficient way possible. Low-cost fertilizers often prioritize concentration over availability. Nutrients are present, yes, but not synchronized with plant uptake. Nitrogen moves too fast, phosphorus locks up, potassium leaches. What the crop does not absorb becomes loss. Loss into groundwater, loss into the atmosphere, loss into imbalance. The producer responds by increasing rates. More product, same result, higher dependency. This is where the system starts eating itself. Repeated chemical stress reduces microbial diversity. Fungi that help with nutrient exchange decline. Bacteria that stabilize soil aggregates disappear. Organic matter stops cycling properly. The soil becomes compacted, less aerated, less responsive. Water infiltration drops. Roots struggle. Crops become more dependent on external correction. At this point, the operation is no longer producing crops. It is maintaining symptoms. The cost shows up as input intensity. More fertilizer per hectare, more corrective applications, more micronutrients, more soil conditioners, each one justified individually. Together, they form a silent tax on productivity. Cheap production also encourages uniformity. One formula for every field, one rate for every hectare. Variability is ignored because measuring it costs money. Precision is avoided because it feels expensive. Ironically, this lack of precision increases waste. Nutrients are overapplied where they are not needed and underapplied where they are critical. Yield potential flattens, risk increases, and then comes water. Degraded soil does not hold water. It sheds it. In dry years, crops suffer faster. In wet years, fields flood sooner. Erosion accelerates. Topsoil disappears one storm at a time. No invoice arrives for this loss. No alert sounds. The cost is paid in resilience. And resilience is the first thing producers need when climate stops behaving. At this stage, producers often blame external forces. Climate volatility, regulations, market prices, rarely the system itself, because the system was built through a series of reasonable, cost-saving decisions. Each one defensible, together, destructive. Cheap inputs do not destroy soil overnight. They make soil irrelevant. They turn it into a passive medium instead of an active partner. And once soil stops contributing, everything else must compensate. That compensation is never cheap. The most dangerous part is that soil degradation still produces crops. Until it doesn't, the decline is nonlinear. Slow, 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 then sudden. When yields finally collapse, recovery is no longer a season-long project. It is a multi-year reconstruction. Organic matter takes years to rebuild. Biology takes longer. Trust in the land takes longest. This is the hidden cost no spreadsheet captures. You can replace a machine. You can refinance debt. You cannot quickly replace soil function. Cheap production doesn't just lower margins. It mortgages the future of the land. And mortgages always come due. After soil, the next system to absorb the hidden cost of cheap production is machinery. This is where the illusion becomes almost elegant. Numbers line up, budgets close. The purchase feels like a win. A cheaper machine promises the same function for less money. Same horsepower, same capacity, same brochure language. What it doesn't promise is continuity. And continuity is where production lives or dies. Cheap machinery is optimized for acquisition, not operation. Materials are thinner, tolerances are tighter, components are pushed closer to failure thresholds. In controlled conditions, it works. Agriculture does not offer controlled conditions. Harvest does not wait for parts availability. Planting does not pause for maintenance schedules. When a machine fails at the wrong moment, the cost is not mechanical. It is biological and temporal. Crops mature, moisture changes, quality drops, loss compounds by the hour. Downtime is the most expensive input no one budgets for. Cheap equipment also increases cognitive load. Operators compensate subconsciously. They drive more carefully. They monitor sounds. They adjust behavior to protect the machine. This mental overhead reduces efficiency. Fatigue increases. Mistakes happen. Productivity quietly drops. Maintenance becomes reactive instead of preventive. Small failures are ignored because fixing them, later, feels cheaper. Later arrives as cascade failure. One worn component damages another. Repairs multiply. What could have been a scheduled stop becomes an emergency. The spare parts economy exposes another hidden cost. Cheap machines often rely on fragmented supply chains. Parts are not standardized. Availability is unpredictable. When something breaks, the machine is not just broken. It is idle. Idle machines generate no value but continue to depreciate. This forces operational redundancy, backup equipment, rental machinery, emergency outsourcing. All of it costs more than the original savings. But none of it is linked back to the original decision. The accounting system treats these as separate problems. The system logic remains unchallenged. Fuel efficiency is another silent leak. Slightly higher consumption per hour feels irrelevant. Over a season, it becomes massive. Over years, it reshapes margins. Cheap engines burn value invisibly, 1 hour at a time. Technology integration suffers too. Cheaper platforms often lack compatibility with precision tools, data systems, or automation. Retrofitting becomes expensive or impossible. The operation locks itself out of future efficiency gains. Innovation becomes structurally harder, not strategically avoided. This is how cheap machinery creates expensive rigidity. The most dangerous effect is normalization. When breakdowns become routine, the operation adapts around inefficiency. Schedules include buffer time for failure. Productivity expectations drop. Loss becomes normal. At that point, the system is no longer optimizing. It is coping. Coping feels sustainable until pressure increases. Higher labor costs, narrower weather windows, tighter margins. When stress rises, fragile systems collapse first. Cheap machines don't fail more loudly. They fail at the worst possible time. And timing, in production, is everything. When soil and machinery start leaking value, the pressure doesn't disappear. It moves, and it almost always lands on labor. Cheap production systems demand more human correction, more supervision, more improvisation, more decisions made under stress. What automation, precision, and reliability should absorb, people are forced to compensate for. At first, this looks manageable. Workers stay longer. Managers monitor more closely. Everyone steps up. The system praises resilience. In reality, it is extracting unpaid complexity from human beings. Cheap inputs increase variability. Variability increases decision load. Decision load increases error probability. Error probability increases cost. The cycle feeds itself. Skilled labor feels this first. Experienced operators notice inefficiencies immediately. They feel machines fighting them. They see crops responding unevenly. They know when a system is held together by duct tape and hope. And skilled people do not stay in systems that waste their competence. Turnover rises. Training costs increase. Institutional knowledge leaks out the door. New workers take longer to reach baseline performance. Mistakes multiply. Quality control degrades. Each individual issue seems small. Together, they form a chronic productivity drag. Cheap production also compresses margins, which compresses wages. When compensation stagnates, motivation erodes. Safety shortcuts appear. Fatigue becomes normal. Accidents increase. These costs rarely show up as production strategy failures. They appear as HR issues, insurance claims, or bad luck. But the system created them. Managers absorb another invisible burden. They become firefighters instead of planners. Time once spent optimizing, analyzing data, or improving processes is consumed by crisis management. Long-term thinking dies under short-term pressure. This is where innovation suffocates. A stressed workforce does not experiment. It avoids risk. It repeats what barely works because failure feels too dangerous. Precision tools are seen as extra work. Data collection is skipped. Feedback loops break. The system stagnates. Cheap systems also erode accountability. When everything is fragile, no single failure feels decisive. Responsibility diffuses. That's just how it is, becomes the default explanation. Mediocrity becomes systemic. The psychological cost matters too. Constant correction creates chronic stress. Stress reduces attention. Reduced attention increases error. Error reinforces stress. This loop is not theoretical. It is measurable, and it is expensive. None of this appears on a purchase invoice. Yet labor inefficiency is often the largest operational cost. And cheap production designs maximize it. The irony is sharp. Companies try to save money by cutting costs, then burn far more by exhausting people. You can underinvest in systems or overinvest in human correction. One way or another, someone pays. And in cheap production models, it is almost always the people. When soil, machinery, and labor are all compensating for inefficiency, risk stops being an external threat and becomes an internal feature of the system. Cheap production increases exposure, not dramatically, gradually, quietly. Every shortcut removes a layer of redundancy. Every delayed investment thins the margin for error. The system still functions, but it loses shock absorption. Weather volatility exposes this first. A resilient operation can absorb a bad week. A cheap one cannot. Poor soil structure amplifies drought stress. Fragile machinery cannot exploit short weather windows. Overloaded labor misses timing. What would have been a manageable fluctuation becomes a yield event. Markets amplify it next. Cheap production locks producers into commodity behavior. Low differentiation, low flexibility, high price sensitivity. When prices drop, there is no buffer. When input costs rise, margins evaporate instantly. The operation becomes reactive, chasing cost reductions instead of value creation. This creates a dangerous feedback loop. Falling margins justify more cost cutting. Cost cutting increases fragility. Fragility increases losses. Losses demand more cost-cutting. The system spirals downward while appearing rational at every step. Financial risk also compounds invisibly. Cheap assets depreciate faster. Emergency repairs distort cash flow. Short-term financing fills gaps created by operational inefficiency. Debt becomes structural instead of strategic. At this stage, decision-making changes. Risk is no longer evaluated. It is avoided. Producers stop asking, "What improves the system?" and start asking, "What keeps us alive this season?" Survival mode replaces optimization. Insurance becomes another silent crutch. Coverage expands. Premiums rise. Claims increase. Insurers adjust terms. Risk pricing tightens. The operation pays more to insure a system that keeps generating preventable losses. None of this is random. Cheap production does not eliminate risk. It concentrates it. It removes buffers and bets that nothing goes wrong. Agriculture, manufacturing, and supply chains do not reward that bet. Systemic risk has another property. It is contagious. One failure cascades into others. A delayed harvest affects storage. Storage affects quality. Quality affects contracts. Contracts affect cash flow. Cash flow affects input decisions for the next cycle. One weak link propagates forward in time. By the time the damage is visible, the original, cheap, decision is long forgotten. This is why cheap systems feel fine until they don't. There is no gradual warning alarm. There is a cliff. The most expensive failures are not catastrophic events. They are predictable ones that systems were too fragile to absorb. Cheap production is not risky because it is aggressive. It is risky because it removes resilience. And resilience is the only real insurance production systems have. The most powerful illusion in cheap production is accounting. Numbers look clean. Costs are categorized. Margins are calculated. Decisions feel objective. The problem is that most accounting systems are blind to systems. They track transactions, not consequences. When a producer buys a cheaper input, the cost is logged immediately. When that input reduces efficiency, increases variability, or degrades soil function, the cost is delayed and displaced. It shows up later under different categories: yield fluctuation, maintenance, labor overtime, risk exposure. None of them point back to the original decision. This fragmentation protects bad strategy. Spreadsheets reward decisions that minimize visible cost, not total cost. They favor actions that are easy to quantify, not those that improve system performance. Soil biology has no depreciation schedule. Resilience has no skew. Timing has no invoice. So decision makers optimize what they can see and ignore what they can't. This creates perverse incentives. Managers who cut budgets look competent. Managers who invest in prevention look expensive. Short-term savings are praised. Long-term stability is questioned. The system selects for behavior that weakens itself over time. Cheap production thrives in this environment because it produces immediate, measurable wins. The losses are externalized into the future, into other departments, or into the environment. Capital allocation becomes distorted. Money flows toward assets that look efficient on paper, not those that improve throughput, reliability, or optionality. Preventive maintenance is minimized. Monitoring systems are postponed. Data infrastructure is labeled nice to have until it becomes too late to implement. This accounting blindness also distorts ROI analysis. Investments in precision agriculture, better genetics, or soil regeneration often appear expensive because their benefits are distributed across years and systems. Meanwhile, cheap inputs appear efficient because their damage is diffuse. The result is underinvestment in intelligence and overinvestment in correction. Another subtle effect is decision speed. Cheap decisions are fast. They require less justification. They fit inside existing approval frameworks. Strategic investments move slowly. They demand explanation, alignment, and patience. In high-pressure environments, speed wins. Speed feels like agility. In reality, it is often avoidance. The system becomes locked into low-resolution thinking. Instead of asking how value is created, it asks where cost can be removed. Instead of designing for robustness, it designs for survival. Over time, this erodes competitive advantage. The most dangerous moment is when the numbers still work. As long as the operation remains barely profitable, the illusion holds. Warning signs are dismissed as noise. Structural weakness is mistaken for normal volatility. By the time margins collapse, recovery requires massive capital, time, and trust. Accounting didn't fail. It did exactly what it was designed to do. It just wasn't designed to see reality. Cheap production survives on that blindness. And systems that cannot see themselves cannot correct themselves. Cheap production does more than weaken systems. It shapes identity. It teaches operations who they are allowed to be. When an organization defines itself by cost minimization, every decision passes through the same filter. Is it cheaper now? If not, it is postponed, reduced, or rejected. Over time, this logic becomes culture. Culture is harder to change than infrastructure. In cost-obsessed systems, ambition shrinks. The goal is not to lead, but to survive. Not to build advantage, but to avoid disadvantage. Strategy turns defensive. Innovation becomes suspicious. Anyone proposing long-term investment is labeled unrealistic. This mindset repels progress before numbers are even discussed. Talent notices. High-performing people want leverage. They want tools, data, and systems that amplify their impact. Cheap production environments offer the opposite. Constraint, patchwork solutions, endless compromise. The best people leave first. Those who stay adapt downward. The organization learns to function below its potential. Technology adoption follows the same pattern. Advanced tools require stable foundations. Precision agriculture needs consistent data. Automation needs reliable processes. AI needs clean inputs. Cheap systems provide none of that. So technology fails, not because it is ineffective, but because the environment is hostile to it. These failures reinforce skepticism. We tried that. It didn't work. What failed was not the tool. It was the system it was dropped into. Competitors who invest differently start compounding advantage. They don't necessarily produce more in the first year. They produce more consistently, more predictably, more controllably. Over time, they gain optionality. They can pivot. They can absorb shocks. They can negotiate better terms. Cheap producers lose optionality. This is the strategic cost that never appears in financial reports. The inability to respond, the lack of flexibility, the dependence on favorable conditions. When markets shift, regulations tighten, or climate volatility increases, resilient systems adapt. Cheap systems break or retreat. They become price takers instead of value creators. The tragedy is that this outcome feels inevitable to those inside it. That's just the business. It isn't. It's the result of accumulated decisions that optimized for the wrong metric. Cheap production trains organizations to think small, not because people lack vision, but because the system punishes it. And once vision disappears, even survival becomes temporary. The opposite of cheap production is not expensive production. That misunderstanding keeps a lot of bad systems alive. The real alternative is intelligent production. Intelligent production starts by redefining cost, not as money spent, but as value lost or preserved across the system. It asks different questions. How stable is output under stress? How predictable is performance? How fast can the system recover from failure? These questions feel abstract until volatility hits. Then they become everything. Intelligent systems invest where leverage is highest. Soil biology before yield maximization. Reliability before capacity. Data before automation. Training before expansion. These investments often look inefficient in isolation. Together, they reduce variance. Variance is the true enemy of profitability. Lower variance means fewer surprises. Fewer surprises mean better planning. Better planning improves timing, purchasing, logistics, and market access. Margins improve not because costs drop, but because waste disappears. This is why high-performing operations often look boring. Machines run when expected. Crops respond predictably. People know what to do. Crises are rare. When they happen, they are absorbed instead of amplified. Cheap systems chase low averages. Intelligent systems protect worst-case outcomes. Technology fits naturally into intelligent production because the foundation exists. Sensors produce usable data. Precision tools act on meaningful variability. Automation reduces labor stress instead of increasing it. AI augments decisions instead of guessing blindly. The ROI shows up everywhere and nowhere. Slight yield stability, lower input correction, fewer emergency repairs, reduced overtime, better quality consistency. Each gain is modest. Together, they compound. This is where cheap thinking collapses. It cannot explain compounding. It sees only line items. Intelligent production also reframes sustainability, not as a moral obligation, but as operational necessity. Systems that regenerate soil, reduce waste, and stabilize inputs are cheaper to run over time. Not because they are virtuous, but because they leak less value. The most counterintuitive insight is this: intelligent systems often have higher upfront costs and lower total costs. Cheap systems invert that. Low entry cost, High lifetime cost. Once this becomes visible, the entire cost conversation changes. Price stops being the decision trigger. System impact becomes the metric. And at that point, cheap stops being attractive. Once producers start seeing systems instead of prices, a strange thing happens. The past becomes legible. Decisions that once felt unlucky reveal their logic. Yield instability, chronic repairs, labor turnover, financial stress, none of it was random. It was the delayed output of a strategy that optimized for immediacy instead of durability. This realization is uncomfortable. It challenges identity. Nobody likes admitting that reasonable decisions produced fragile systems. So many operations stay stuck not because they don't understand the problem, but because accepting it feels like failure. It isn't. It's clarity. The shift away from cheap production doesn't happen through a single upgrade. It happens through reframing. Cost is no longer a question of how little can we spend, but where does value erode if we don't invest? This reframing changes priorities. Soil health stops being an agronomic concern and becomes a financial asset. Maintenance stops being a cost center and becomes risk management. Training stops being overhead and becomes leverage. Progress becomes directional, not immediate. The most effective transitions are incremental. Stabilize soil before chasing yield. Improve reliability before expanding capacity. Measure variability before buying technology. Each step reduces fragility. Each reduction unlocks the next improvement. This is not about perfection. It's about trajectory. Cheap systems decay by default. Intelligent systems improve by design. One of the hardest lessons is patience. The benefits of smarter investment rarely explode. They accumulate. This makes them invisible to systems addicted to fast feedback. But compounding does not need applause. It only needs time. Operations that survive long enough to see this shift often become remarkably durable. They don't win every season. They don't avoid all losses. But they avoid collapse. They remain in the game while others cycle in and out. Staying in the game is an advantage most people underestimate. Because exit is expensive, re-entry is harder, and rebuilding trust, land, and teams takes longer than any spreadsheet predicts. Cheap production creates exits. Intelligent production creates continuity, and continuity is where real value lives. Cheap production survives because it feels rational. It speaks the language of discipline, efficiency, and control. It promises safety in an industry built on uncertainty. But that promise is conditional. It only holds as long as nothing goes wrong. Production systems are not tested by normal conditions. They are tested by stress. Weather shocks, market swings, supply disruptions, labor shortages, regulation. When stress arrives, cheap systems reveal what they are missing. Buffers, redundancy, intelligence. The cost of cheap production is not hidden forever. It is delayed. It accumulates quietly across soil, machines, people, and decisions. Then it surfaces all at once, labeled as crisis. At that point, options shrink. Decisions become defensive. Capital becomes expensive. Time becomes scarce. The system pays interest on every shortcut it ever took. The alternative is not to spend blindly. It is to spend deliberately. To invest where systems amplify value instead of leaking it. To accept higher upfront costs in exchange for lower long-term risk. To design operations that fail slowly instead of catastrophically. This is not idealism. It is engineering. Intelligent production does not chase the cheapest option. It chases the most stable outcome. It understands that profitability is not about peaks, but about survival through valleys. In the long run, every operation pays for what it ignores. Soil function, reliability, people, data, timing. Cheap production ignores them because they are inconvenient to measure. Reality measures them anyway. The question is not whether you pay the cost. The question is when, and how much control you have when you do. Cheap production gives you the illusion of choice today. Intelligent production gives you real choice tomorrow. And in a volatile world, choice is the most valuable output of all. Cheap production never collapses loudly. That's the part most people misunderstand. It doesn't explode, it erodes. It hollows systems out from the inside while everything still appears functional from the outside. Fields still grow crops, machines still move, people still show up, reports still close. From a distance, nothing looks broken. And that's exactly why the model survives for so long. The danger of cheap production is not failure. It's delayed feedback. Every shortcut pushes consequence into the future. Every underinvestment creates a liability that does not demand attention immediately. Soil degradation waits. Mechanical fatigue waits. Workforce burnout waits. Risk accumulation waits. And because nothing demands payment upfront, the system convinces itself that the strategy works. Until timing turns hostile, the moment conditions shift, cheap systems are exposed. Weather tightens planting windows, markets compress margins, supply chains stretch lead times, labor availability drops, regulation increases complexity. Suddenly, there is no buffer, no margin, no flexibility. Every weakness surfaces at once. What follows is not a single mistake. It's a cascade. Producers respond the only way fragile systems can, by cutting further. Inputs are reduced, maintenance is delayed, monitoring is skipped, training is postponed, decision-making narrows. The system enters survival mode, not realizing that survival mode accelerates collapse. This is the final irony. Cheap production creates the conditions that justify more cheap production. The loop closes on itself. From the inside, this feels like bad luck. From the outside, it's predictable. Because systems don't fail randomly. They fail according to how they were designed. The alternative path has been visible this entire time, but rarely named clearly. It is not luxury production. It is not over-engineering. It is not idealism. It is systems thinking applied without sentimentality. Intelligent production accepts one uncomfortable truth. You either pay up front, or you pay with interest later. Upfront payment looks like investment. It feels heavy. It attracts scrutiny. It slows decision-making. It demands patience. And because its benefits are distributed over time, it looks inefficient to minds trained on quarterly outcomes. But over years, intelligent systems reveal their advantage in the only metric that truly matters: continuity. They don't avoid bad seasons. They absorb them. They don't eliminate risk. They localize it. They don't maximize peaks. They raise the floor. This is what spreadsheets miss. Profitability is not created in the best year. It is protected in the worst one. Soil health becomes capital. Reliability becomes leverage. Data becomes foresight. People become multipliers instead of shock absorbers. Technology stops being decoration and starts being infrastructure. These systems do not look dramatic. They look calm, predictable, almost boring, and that boredom is the signal. It means chaos has been engineered out. Cheap systems are exciting in the beginning. They feel fast, decisive, lean. Intelligent systems feel slow at first. Deliberate, heavy, conservative. Then time flips the scoreboard. Years later, cheap systems are busy surviving. Intelligent systems are choosing markets, choosing crops, choosing technology, choosing direction. Choice is the rarest resource in production. Once choice disappears, every decision becomes reactive. And reactive systems do not compound. They decay. This is why the true cost of cheap production is not measured in money. Money can be recovered, loans can be refinanced, assets can be replaced. What cheap production really destroys is optionality. And once optionality is gone, the future narrows fast. The final lesson is simple, but uncomfortable. No system escapes reality. Every decision leaves a trace. Every shortcut writes a bill. You may not see it this season. You may not see it next year. But the bill always arrives. The only question is whether you designed your system to be ready when it does. Cheap production gives you comfort today. Intelligent production gives you control tomorrow. In a world defined by volatility, control is not a luxury. It is survival.